Electrolytic conductors. Electrolytic or liquid conductors are liquid substances or solutions of substances which allow electricity to pass through them. This type of conductivity is due to the movement of ions from one point to another within the solution. The liquid undergoes dissociation when electricity passes through it and thus conducts electricity. Example, aqueous solutions of sulfuric acid, hydrochloric acid, sodium chloride, acidified copper sulfate solution and water, etc. Chemical equations. Symbol. A symbol is the short and scientific representation of an element. For example, alphabet C represents carbon. Valency. Valency is the combining capacity of an element. Example, in water, two atoms of hydrogen combine with one atom of oxygen so that the valency of oxygen is 2. Radical. It is a group of two or more atoms having a net charge, which may be positive or negative. For example, the valency of chloride minus equal to 1, that of sulfate to the power of 2 minus equal to 2. Variable valencies. Some elements exhibit more than one valency. This phenomenon is known as variable valency. Example, iron has valencies 2 and 3. Tin has valencies 2 and 4. The names of compounds of metals with lower valency end with OUS. Example, ferrous oxide, and that with higher valency end with IC. Example, ferric oxide. Chemical formulae. The symbolic representation of a compound is called its chemical formulae. If the elements are present in the compound, it is called its chemical formulae. If the elements present in the compound and their valencies are known, it is possible to write the formula. Step 1. Write the symbols of the elements or ions that combine. Step 2. Write their valencies on the top right-hand side of the symbols. Step 3. Interchange valencies and write the numbers as subscripts. Step 4. If the valencies are divisible, the simplest whole numbers are given in the formula. Chemical equation. A chemical equation is a short, scientific, and symbolic way of representing a chemical reaction. Step 1. The substances that undergo the chemical change, reactants, and the substances that are formed, products, should be known. Symbols and formulae of the substances that are undergoing chemical change must be written on the left-hand side with plus sign between them. In the same way, symbols and formulae of the products must be written on the right-hand side with plus sign between them. Step 2. To show that the reaction proceeds from the reactants to the products, an arrow is to be drawn from left to right. Example, reactants give products. Sulfur plus oxygen gives sulfur dioxide. Step 3. The equation should be obtained by making the number of atoms on the left-hand side equal to the number of atoms on the right-hand side. Adjust the number of molecules of the substance by multiplying the formula by suitable number. Gaseous substances are represented by upward arrow. Precipitated products are represented by downward arrow. Conditions to carry out the chemical change over the forward arrow mark: heating, catalyst, burning, etc. Reversible reactions are represented by reversible sign. Naming of compounds. When a metallic radical combines with a non-metallic radical, a compound is formed. To write the name of the compound thus formed, write the name of the metal first. Example, calcium. Write the name of the non-metallic radical next. Example, carbonate. In the case of metals exhibiting variable valencies, the suffixes OUS and IC are added to the names of the metallic radical with lower and higher valencies respectively. Essential for a chemical equation. The chemical charge should be practically possible. It should follow the law of conservation of mass. It should be a molecular balanced equation. Balancing of chemical equations. Hydrogen combines with oxygen to form water. The reactants are hydrogen and oxygen. The product is water. The skeleton equation for the above equation is hydrogen plus oxygen gives hydroxide. Hydrogen and oxygen always exist in molecular state. Write these two elements in their molecular state. H2 plus O2 gives H2O. This is an unbalanced equation because the numbers of hydrogen atoms are equal on either side, but the numbers of oxygen atoms are not equal. So, put 2 before water molecule. We get H2 plus O2 gives 2 H2O. In the equation, the number of oxygen atoms on either side will become equal. In order to make the number of hydrogen atoms equal on the reactant side, put 2 before hydrogen. Thus, the equation becomes a balanced equation. This process of making the number of atoms equal on both sides of an equation is called balancing the equation. Molecular weight. It is defined as the sum of atomic masses of all the atoms present in a molecule of a compound. Molecular weight of a compound is represented by atomic mass unit, AMU. Example, molecular weight of calcium carbonate. Atomic weights: calcium equal to 40, carbonate equal to 12, oxygen equal to 16. Calcium carbonate gives CaCO3. Weight of one atom of calcium equal to 1 into 40 equal to 40. Weight of one atom of carbonate to 1 into 12 equal to 12. Weight of 3 atoms of oxygen equal to 3 into 16 equal to 48. Equal to 100 AMU. Therefore, molecular weight of calcium carbonate equal to 100 AMU. Information supplied by chemical equations. A chemical equation gives us the following informations: the name of the reactants and the products, the nature of the reaction and the products, the number of atoms or molecules of the reactants and the products, the relative weights of the reactants and the products, the relative volumes of the reactants and products which are gaseous in nature. Limitations of chemical equation. Ordinary chemical equation does not indicate the following: the speed of the reaction, whether it is fast or slow, the energy changes that occur during the reaction, whether heat is liberated or absorbed, the optimum conditions such as temperature, pressure, catalyst, etc., under which the reaction takes place, the reaction rate, whether the reaction goes to 100% completion or not, the state and concentration of the reactants.